Take a moment and picture a ceiling fan. It's probably spinning slowly above your head right now. Or maybe you're imagining one in your living room or bedroom. But here's a small question most people never think about. Why do ceiling fans almost always have 3 blades? Not 2, not 6, and rarely anything different. Once you notice it, it's actually everywhere. In homes, offices, restaurants, classrooms, most ceiling fans follow the same design. 3 blades spinning around a central motor. And at first glance, it might seem like a random design choice. Maybe manufacturers just picked 3 because it looks nice. But the truth is, there's actually a very interesting reason behind it. In fact, engineers have spent decades experimenting with different numbers of blades, 2, 3, 4, even more. And what they discovered is something surprising. The number of blades on a fan affects 3 very important things: how much air it moves, how much noise it makes, and how much electricity it uses. In other words, that simple spinning fan above your head is the result of a lot of engineering decisions. And oddly enough, if you look back in history, ceiling fans didn't always look the way they do today. Early fans had very different designs, and some of them worked in ways that would probably feel strange if you saw them today. But over time, engineers kept refining the design, testing what worked best and what didn't. Eventually, one particular design kept appearing again and again. A design that balanced efficiency, cost, and comfort almost perfectly. And that design involved something surprisingly simple. Just 3 blades. But to understand why 3 became the sweet spot, we first have to look at a much simpler question. What exactly is a ceiling fan supposed to do? At first, a ceiling fan seems like a very simple machine. It spins, and somehow the room feels cooler. But interestingly, a fan doesn't actually lower the temperature of the room the way an air conditioner does. It's not creating cold air. What it's really doing is moving air around your body. When air flows across your skin, it speeds up the evaporation of sweat and helps carry heat away from your body. That's why even warm air can feel cooler when a fan is blowing. So the job of a ceiling fan is pretty straightforward. Move as much air as possible, as smoothly as possible. But there's a challenge. If the fan blades are poorly designed, 2 things can happen. The fan becomes noisy or it becomes inefficient. For example, imagine a fan with only 1 blade. Technically, it could spin, but it would wobble like crazy and barely move any air. Now imagine a fan with 10 blades. It might look impressive, but those blades would create a lot of air resistance. The motor would have to work harder, use more electricity, and the airflow could actually become weaker. So engineers had to find the balance. Too few blades, and the fan becomes unstable and ineffective. Too many blades, and the airflow becomes restricted while the motor works harder. Some early industrial fans actually experimented with 2 blades, which made them very fast and efficient. But they had a big problem. They were often loud and slightly unbalanced, especially when installed on ceilings. So designers began testing other options. 3 blades, 4 blades, 5 blades, different shapes, angles, and sizes. After years of testing and refinement, something interesting started to appear. For most situations, 3 blades created one of the best balances between airflow, stability, and efficiency. But there's another surprising reason. Manufacturers often stick with 3 blades. And it has a lot to do with something companies think about all the time. Cost. When companies design everyday products, they don't just think about how well something works. They also think about something equally important. How much will it cost to make? This matters a lot when you're producing millions of units. Now think about a ceiling fan for a second. Each blade requires materials like metal, plastic, or wood. It needs to be shaped, balanced, finished, and attached securely to the motor housing. Even small changes in design can affect manufacturing costs. If you add more blades, several things happen. First, the fan becomes heavier. That means the motor has to be stronger to spin it properly. Second, more blades mean more materials and more assembly work during production. Third, balancing the fan becomes more complicated. Every blade must be nearly identical in weight and angle, otherwise the fan may wobble when spinning. Manufacturers discovered that using 3 blades often gives the best balance between performance and cost. With 3 blades, the fan can still move plenty of air while keeping the structure simple and lightweight. The motor doesn't need to work as hard, and production becomes easier. Adding a 4th or 5th blade can sometimes make the fan look more stylish or reduce noise slightly, which is why you'll still see those designs in some homes. But from a manufacturing point of view, 3 blades often provide a very efficient and practical design. In other words, it's not just about airflow. It's also about creating a fan that can be produced affordably and reliably. But there's another factor engineers had to think about as well. Because when a fan spins above your head for hours every day, something else becomes extremely important: stability. Another big reason ceiling fans often use 3 blades has to do with something engineers care deeply about: balance. When a fan spins, especially at higher speeds, every part of it needs to stay perfectly stable. If the weight isn't distributed evenly, the fan can start to wobble. You might have seen this before. A fan that shakes slightly, makes a rattling sound, or looks like it's struggling to stay steady while spinning. Over time, that wobbling can loosen screws, wear out the motor, and even shorten the fan's lifespan. This is where the number of blades becomes important. With 3 blades, the weight of the fan is naturally distributed evenly around the center. Each blade sits exactly 120 degrees apart from the others, creating a balanced triangular layout. That simple geometry helps the fan spin smoothly without putting unnecessary stress on the motor. If there were only 2 blades, the fan could still work, but it would be more sensitive to small weight differences. Even a tiny imbalance could make the fan shake. With many more blades, the fan might look fuller, but it also becomes heavier and can create more air resistance. That means the motor has to work harder to keep everything spinning. 3 blades often hit a sweet spot: balanced, stable, and efficient. But interestingly, if you look around today, you'll notice something curious. Not every ceiling fan has 3 blades. Some have 4, some have 5, and occasionally you'll even see fans with 6 or more. So if 3 blades work so well, why do companies sometimes add more? An XD. If 3 blades are so efficient, you might wonder why many ceiling fans today have 4 or 5 blades instead. The answer is surprisingly simple: comfort and design preferences. Fans with more blades tend to move air a little differently. Instead of pushing large amounts of air quickly, they create a smoother and quieter airflow that can feel more comfortable in certain indoor environments, especially bedrooms or offices where people want less noise. More blades can also help distribute the air more evenly around a room, which some people prefer. But there's another factor that has nothing to do with engineering: appearance. Over time, ceiling fans became part of interior design. Homeowners and designers started choosing fans not just for airflow, but also for how they look in a room. A fan with 4 or 5 blades often appears fuller and more decorative, which many people find visually pleasing. So manufacturers began producing different styles to match different tastes. However, from a purely functional perspective, many engineers still consider 3 blades to be one of the most efficient and balanced designs. It moves air effectively, keeps the motor load reasonable, and maintains good stability. That's why you'll still see 3-blade fans used in many modern designs, especially where efficiency and simplicity matter. And once you start noticing it, you'll probably see this pattern everywhere. The next time you look up at a ceiling fan slowly spinning above you, remember that something that seems simple, just a few blades moving air, is actually the result of years of engineering, testing, and small design choices that most of us never think about. Sometimes the simplest designs end up lasting the longest.